Simple voltmeter using 7107 IC. This circuit is displaying 5 volts because it is connected to this 5 volt voltage regulator. These two wires are connected to the reference pin of this chip. This chip then processes that and distributes the signal to these 4 7-segment displays. If the voltage was negative, this 7-segment display would show a negative sign. This chip only accepts 5 volts, so here is a 5 volt voltage regulator used to drive the circuit. There are many parts to this circuit. One is a negative voltage generator using the LCM7660 IC, or these 3 pins which generate the frequency for the circuit, and this potentiometer, which is used to set the sensitivity for the circuit. This circuit can display 3.5 digits. In this iteration of the circuit, I've set it up so it displays these 3 from 1 to 9, and this will display whether it's a negative or positive voltage. However, this chip and circuit has the capacity for this 4th 7-segment display to show 1 for higher voltage applications. This can be altered using this potentiometer. This chip uses a dual slope analog to digital, or ADC, conversion method, which is known for its accuracy and its resistance to noise. The dual slope integration method used by the ICL 7107 is a simple and accurate way to convert an analog signal, like voltage in this case, into a digital signal. There are 2 main phases. First, the integration phase. The input voltage is applied to an integrator circuit, which is essentially a capacitor. For a fixed period of time, the integrator charges the capacitor, causing its output voltage to rise, or in some cases fall, at a proportional rate to the input voltage. The higher the input voltage, the steeper the slope. Secondly, the deintegration phase. After the fixed integration time, the IC switches to a known reference voltage of the opposite polarity and applies it to the integrator. This causes the capacitor to discharge at a steady rate. The time it takes for the capacitor's voltage to return to 0 is measured. The IC counts the clock pulses during the deintegration phase. The number of clock pulses is directly proportional to the input voltage, because the higher the input voltage causes the capacitor to charge more, requiring more time to discharge. The IC processes the counted clock pulses and converts them into a digital value, which will then be displayed on these 4 7-segment displays, depending on how it's calibrated.